Okay, so that we already learned last week. But if you want volume, you integrate the area formula, and that's going to give you what the volume is. Okay, so what we're going to do today is if you're rotating. So look at number 1. Go ahead and sketch the graph of it. So it says, let R be the region bounded in the first quadrant by square root x, x-axis, and x equals 4. So square root x is here.
Is this morning service?
This is the last new thing is this week.
Swear?
Swear. This is the end of the volume unit. Okay, and then x equals 4 we'll put here. Okay, so shade your region. We need to stay in the first quadrant. So you're shading this. Okay, ready? What you are going to do is, I want you to read it, says, find the volume of the solid generated by rotating this region R around the x-axis. So what you're going to do is, this is the x-axis, obvi, okay, and you're going to take that and you're going to spin it around and it's going to make a shape. Now, what do you envision if you were to try to draw it? Yeah, it'd make a circle kind of like a bullet, yeah? So you'd have each of these are rotating around and you would end up with kind of like a bullet shape. Okay, it's just your last topic. Okay? It would go, yeah, I'm just drawing it kind of like part way around. Okay, so your thing is going to be rotating around, and you're going to end up that if I were to slice this shape, remember last week we were slicing to see what the middle shape was. Sometimes it was a square, sometimes...
Why is it like that?
Because you're rotating it around the x-axis. So you'd be rotating it where this part stays where it's at, and this part is rotating around.
It's like 3D?
Yes, it's like three-dimensional. Okay?
Do you have to do this?
Yes, it's on the AP test. Or else why would I make you do it? What's
You
on
have to
the
do a
AP
lot
test?
of stuff. Facts.
Okay, so I want you to think about if this is your cross section, what shape did we say that is? Even though it's three-dimensional, it would be a what? A circle. So if you're revolving, okay, come over here. It'll be pi integral a, well, because it's three-dimensional.
A 3-dimensional circle.
Like, yeah, it does. If you were to cut into it. So imagine if that was a bullet and you sliced it, you would, and then you turned it and looked, it would be a circle. Okay? So,
It's not a musket ball. It's like...
okay, write that down right there.
I'm having a hard time with it.
Okay, I'm about to pull up some pictures on the computer to help with that. Okay, so it'll be pi integral, and then r of x squared. And actually, let me put parentheses around this to show that you're squaring the entire radius function. Okay, and then I'm going to put over here, your r of x is usually going to be top minus bottom. Okay, which is also very similar to what we did last week. Now, because drawing these kind of sometimes helps, sometimes it doesn't really help, but I'm just going to pull up some pictures on the computer. Okay, but since I don't want to turn off my recording software, I'm just going to put it under here, so it's going to look kind of ghetto. Okay, but you get the idea. Okay, so ready? If you were to take...
Whoa!
I know, whoa, it's like you're looking at yourself on the thing. Okay. So look. Okay, if you had a certain region... Yeah, just a sec. Let me find like a good picture to use. Okay, so like look at this one. Okay, so do you see that this right here, this is x squared?
Oh.
So here's my initial region, and then I'm rotating it around and it would make kind of like a funnel shape. Yeah? Okay, ready for another one? Okay, so imagine this is your initial area and then you're spinning it to make it three-dimensional. Okay, let's look at another one. Okay, let's say that we're doing, Okay, this one right here. So look, this is square root x. See how it's even shaded for you?
Yeah.
And then that's if you spin it. Then it would be like a three-dimensional solid.
100 multiplied by 4.
That won't work. Good idea, though. Okay, let's do another one. Okay, this one right here. Okay, if your initial region was this little triangle, and you spin it around, what shape does it make? A cone.
Code.
Okay. Let's do maybe one more. Okay, this is the first part of sine, and then you cut it off at pi halves, so that's your region right there. But then you're spinning it around, it makes kind of like a bowl shape. Now, keep in mind, is it a perfect circle? No. It has this random little pointy on the side, so that's not a sphere. You couldn't use a sphere formula because it's not perfectly round. This point here has like a little cusp that a sphere wouldn't have. Okay? Good. Okay, so that's what you're doing, but again, just like last week, visualizing it is not the most important part. What's the most important part? That you know how to find through the same steps over and over again how to set up the volume. Okay? So, let's continue with that. So step 1, you're going to graph it, shade your region. Step number 2, you're going to reflect your graph across the x-axis to get the other half of the picture.
Do we have to? Like, is that
I mean, it's up to you.
I don't know how to draw it.
Okay, so all that you're going to draw is the region, and then you're going to flip it over. That's it. And then draw a circle. That's all that you really need. Okay? So from here, you're going to draw in your radius onto the shape. So my radius is from the border to the middle of the solid. Now, this is different than what we did last week, because last week your whole semicircle was sitting in the region. So I want you to think about, if I wanted to define this radius, it's going to be r of x equals the top border minus the bottom border. Now, what is the top border? We already have an equation for it. Square root x. And what is the bottom border if it's the x-axis? 0. Because remember, we're only looking at the radius, so we're only going to the center of the object. You're not going all the way through. Okay? Then from there, look right here. How do you find volume? It's going to be pi integral a to b. Now, what is my a over here? What's my b over here? 0 to 4. And then I want my r of x, which is my radius, squared. And then think about, well, if it's square root of x and then squared, those can cross out. Really, this is just what? 0 to 4 of x dx. And on the AP test, usually they'll use square root functions so that it kind of works out with the square that they cross out. Okay? So take a look at that from there. What's the antiderivative of x? 1/2 x squared. Notice that I'm pulling the 1/2 out to be with the pi, just to make my antiderivative easier. Then I'm going to put those brackets. Okay, and then we're going to plug in 4 and then 0. 4 squared is 16. 0 squared is 0. 16 minus 0 is 16, but then I have to multiply by the pi halves in the front. So it would be, pi halves of 16, which is 8 pi. So what that means is that the volume of this kind of like bullet shape is 8 pi. Okay. All right, go down to number 2. Okay, we're going to just run through several of these, and then you should have a little bit of time to work on your homework. So it says, let R be the region in the first quadrant bounded by, okay, 2x plus 3, so 1, 2, 3 with a slope of 2. The x-axis and the vertical line x equals 5. Okay, so the first thing I want you to do is shade your region. Now notice, I am not going to shade all the way to here. where it hits the x-axis. The reason why is because it's telling me I need to stay in the first quadrant. So I'm only going to shade from 0 to 5. Okay, so I'm going to go ahead and label this as x equals 0, this is x equals 5. Okay, step number 2, what are we reflecting across? What are we rotating around? Okay, so I'm going to just kind of sketch the other half of this. Okay, it's going to be basically the same shape, and then I'm going to draw in one oval to represent the cross section because it's rotating around that axis. And then I'm going to draw the radius into that. So my radius is here. Okay, r of x equals top minus bottom. What is the top of my radius touching? 2x plus 3. What is the bottom of my radius touching? 0. And then obviously keep in mind, if it's the x-axis you're rotating around, you don't have to put the 0 if you don't want to. Okay, then from there, volume equals pi integral 0 to 5, because those are my border points. And then my r is 2x plus 3 squared dx. Okay? Now, we are going to work all of these on the front out just for practice. So what method would you, actually there's two. What's one method that you could use to integrate this? Okay, U sub. The other option would be to factor it out and expand it. I don't want you to do that because I want you to practice U sub. But yes, that would work. If you want to do that, fine. But let's practice U sub. So, what would your U be? 2x plus 3. That means that your du is just 2 dx, which means that dx is du over 2. So I'm going to rewrite my integral. So it's going to be volume equals pi integral u squared du. And then if I have this over 2, I'm going to put that out in front with the pi. So it's going to be pi over 2. What else do I have to remember to change? Endpoints, very good. So I'm going to take 0 and 5, and I'm going to plug them in here. If I plug in 5, 2 times 5 is 10, plus 3 is 13 on top, and then on bottom 0 plus 3 is 3. Now, what is the antiderivative of u squared?
No, 1/3.
So I have pi halves in the front, and then my antiderivative is 1/3 u cubed. And then remember, on top I'm plugging in 13, on bottom I'm plugging in 3. Now, if you know 13 cubed, I don't know why you memorized that, good job, okay, but unnecessary. So I'm just going to put 13 cubed minus 3 cubed. And then what would need to go in the front of that?
Pi over 6.
Pi over 6, very good. And that would be your answer. Okay? Now, obviously, 3 cubed you probably know. Okay, that's 27. But the other one, it's fine if you don't know it, you just leave it like that. The 1/3 came from the antiderivative of u squared. So we would have added 1 to get u cubed and then put a 1/3. Make sense? Okay, take a look at number 3. This time, you are not revolving around the x-axis anymore. So I want you to sketch your graph, okay, and I'll bring you an Oreo. Okay, so sketch your graph. X squared plus 4, we all know hopefully what that looks like. And then make sure you shade the correct region, and then when you reflect it across, you're not reflecting across the x-axis. You say that again, sorry. No, read what it says. Well, so y equals 4 is this way. So that's going to be your center.
Oh, it's double stuff?
Yep, it does. Okay, so then where's x plus 4 going to be? X squared plus 4.
Yeah.
Oh my God, why is my son on? Your son needs some help.
Look at fix your graph. If it's x squared plus 4, and that's y equals
From
4,
0 to 2.
they should both be touching at 4. You know what I mean? Okay, draw your graph kind of carefully. I know you can do it.
Is this right?
Yep. Good. Now reflect it across. Oh, wait, Jerry, give me one. One? Huh? I did. I thought about sending her like a snap, or whatever it is, remind what I want to see. Like, this is so lit, because it was cute. That would have been hilarious. But I decided I'd just tell her today, so she could enjoy the joke more, you know? Yeah.
So in our that's supposed to be x squared, because it would be x squared plus 4 minus 4.
So then the 4 is just crossed out, yes ma'am. Correct. You want one? You want one of these? You want one? You're so welcome. That looks good. Okay, so shade the part of the graph that you want.
That was so random.
That weird little hidey thing.
No, like I saw a flash.
Maybe somebody has superpower.
Y'all saw that too?
No, I'm not sure.
There was a flash?
Yeah.
I saw it too. You do some drugs today, Marcel? Okay, so look. X squared plus 4. 1, 2, 3, 4. Okay, then y equals 4 is here. So these only cross once at 4. But where are you shading? Not between them. From 0 to 2. That would have only been here. So we'll say that 2 ends about right there. Okay, then it says, find the volume of the solid generated by rotating region R around y equals 4. That's going to put the other half of your graph here. So your graph, when I draw my circle in, is going to look like that. Now keep in mind that your radius, top minus bottom, okay, when I draw it in, which function is the top of the radius touching? Okay, x squared plus 4 minus, and then what part is the bottom of it touching? 4. Now keep in mind, you are not going all the way down here because you only want the radius. Okay, and what's going to happen with the plus 4 and the minus 4? So really it's just an x squared. Okay, then from there, volume equals pi integral, where to where? 0 to 2. And then my function is x squared squared dx, which can be simplified to what? X to the 4th. And what's the antiderivative of x to the 4th? So I'm going to put pi fifths x to the 5th. Then I'm going to plug in 2 and 0. 2 to the 5th is 32. 0 to the 5th is still 0. So your volume is going to equal pi fifths of 32. Good? Sort of? Okay, we have one more example to do like that before we switch to dy. So take a look at the next one. Do any of you remember what shape this is?
Oh, that's
Okay, yes, but it's the square root of x squared. It's a special one. Circle. Okay, so let's review how to solve it. Okay, if I square both sides, so square, square, Then I have y squared equals 9 minus x squared, because remember the squared and the square root cross out. And then I take my minus x squared across to the other side. So it's x squared plus y squared is 9. Did y'all cover this in Algebra 2?
That's a perfect circle.
Perfect circle. Where's the center?
3.
It's in the origin, but each side.
It's in the origin. So here's your general. It's x minus h squared, y minus k squared, and then r squared. So since there's not a number with x or y, your center is going to stay at the origin. Okay, so let's draw a little picture here. Our center is the origin. And then if r squared is 9, what's the radius? So my graph is going to be 3 up, 3 to each side. Now, real quick, don't draw the whole circle. If I had solved this, do you remember how it would have been plus or minus the square root? So remember that the plus square root is the top half of the circle, and the minus square root is the bottom half. And we a little bit covered that a while ago. Okay, so it says, we're bounded above by our circle, and below by the line y equals -1. That would be here. Now, is it a problem that those don't touch each other? No. So when I shade, where am I going to shade from? The whole thing? -2 to 2. And what's my radius extend to? -3. So I need to make sure I cut off here. So I'm leaving the ends of that circle out because I'm only shading from -2 to 2. And then if you want to make a little line there, you can. Okay, but that's x equals -2. That's x equals 2. Okay, now, next thing. What are we rotating around this time? Y equals -1. So if this is my center, then when I reflect this across, I'm going to be here. And my circle is going to be here. Okay? And again, the drawing of this is really not that important. If you can understand it without drawing it, I'm fine with that. They're not going to grade your picture. Okay?
Where do you put the radius at, the line?
The radius should always extend from the center to the outside border. So in this case, my center is -1, and my outside border is the semicircle. And that's going to be the same thing as your r of x. But it has to go top minus bottom. So the outside border would be square root 9 minus x squared. And then -1 would be your bottom. So think about maybe like outside minus center. If that makes you feel better, then that's fine. Okay, and then the minus and -1, we can switch that to a +1. Okay, set up your integral. Volume equals pi on the outside. Where are we integrating from? -2 to 2. And then it needs to be pi r squared. What's my r? All of this. So it'll be 9 minus x squared plus 1 squared. What'd you say? Because the center shape is a circle, since you're rotating it. Yes, yes. So it's always pi, your radius, squared. And the reason why is because you're making a full circle if you're rotating it. Okay, we're not going to do that one. Actually, you couldn't do it by hand anyway. Good. Turn the page.
Will there be like one like that on the homework?
So if you look at your homework, pretty much all of them are graphed for you, just to make it not take as long. Do you guys want to set one up off the homework before we go to DY?
Wait, I got a question though.
Okay,
They're like rectangles. So
do number 2. What'd you say?
like the boxes on there are like rectangles, they're not circles. So like
Yeah, the reason why is because a lot of times on the AP test they'll use a rectangle to not make it look confusing. But it's supposed to be a thick line, is what it's supposed to be. Like a radius, like that I've been drawing in, they're just thicker so that you see it better. So imagine like this is your radius.
Why is this such crappy print?
Because it's really old. Okay? Yeah, that is an x squared. Okay, so change it to a squared if you need to. Okay, so I want you to do 2 things. Now notice on the whole front, it says you're revolving around the x-axis. So I want you to draw your reflection, draw your circle, write your radius, and then write your volume. Now, if you want to, if you don't like that picture, maybe just redraw it, okay? That's fine. There it is. So there's my graph. Here's my region. And then remember that I'm revolving around the x-axis. So that means that when I reflect that across, it's going to end up looking kind of like that. And here's my circle. And the picture that they drew for you is supposed to represent the radius. So I could draw that in though myself, here to here. So my radius equals top minus bottom. What's the top? 4 minus x squared. What's the bottom? 0, which you don't have to write. And then remember that your volume is always pi times the integral from where to where for this graph? 0 to 2. And then it'd be your r of x squared. So pi r squared. Now, I want to point something out to you. If I tried to do u sub on this, it would not work. Okay, this is why. Don't write it down, just watch. Okay, I would pick my u to be 4 minus x squared, right? What does that make my du? Negative 2x dx, right? Because what's the derivative of 4? 0, right? Okay, then what is dx? Du over negative 2x. And if I plugged that back in, do you remember us talking about that you can have extra x's? You're not allowed to pull those out. So if I had tried to rewrite this, it would have been volume equals pi integral u squared du over negative 2x. I can pull the 2 out, but the x messes everything up. So u sub doesn't work. What other method could you use? You could reverse factor or expand it. So you remember square, double square? Okay, so let's use that on it. What is this if I square, double square it? 16 minus, what's the double term? Minus 8x squared. And then what's the last term squared? X to the 4th. And then you would just work it out like that.
What happens if you don't add the middle section?
Then it wouldn't be the right answer at the end. Okay? So then from there, what's the antiderivative of 16? 16x. Antiderivative of 8x squared is 8/3 x cubed. And then x to the 4th would be 1/5 x 5. Now question, since I'm kind of skipping u sub, do I have to change my endpoints? No, they're still a 2 and a 0. Now at this point I messed up. What did I forget to write? Well, the dx is gone, the pi, and also the points, I guess. Okay? So I'd have 2 on top, 0 on bottom. Now imagine for a second that you plugged in 0. What would happen? It's all going to cross out to 0. So my answer is just really going to be me plugging in the 2. So it'd be 32 minus 8/3 of 2 cubed, which is 32. Oh wait, no, 8. And then 1/5 of 32. Okay, and that would be your answer. No. Okay, that would be your answer for that one. Okay? Because when I plug in 0, I end up just getting nothing, so there's no point in me writing it. Okay, back to your notes. Now we're going to do it dy. But I want you to remember that all the stuff that changed for area when we switched to dy is the same stuff that's going to change for volume. Okay, instead of rotating around the x-axis, what do you imagine we're going to be rotating dy? Around the y-axis. So ready? And I can put this back up here if you don't have it yet. Okay. Alright, so we're going to have volume equals, this is back page of your notes, pi integral c to d r of y dy squared. And remember, why is it pi r squared? Because anytime you're revolving, that middle shape is going to be a circle. Okay, but some important things that are going to be different. C to D is going to be the range. So those are going to be y values. And then the other big thing that's going to be different is that your r of y is going to be right minus left. And then I guess one other thing that we'll make a note of is that your equations, because it's dy, they need to be in x equals form instead of y equals form. Okay? So let's run through number 5. Okay, x equals negative 2y plus 4. We're going to start at 4. And then negative 2y, we need to know where to draw it. So we know it's going to go like this. The problem is that we don't know where it hits this axis. How do you find the axis? What do you do with the equation? Set it equal to 0. Very good. So I'm going to let 0 equal negative 2y plus 4. I'm going to take my negative 2y across to the other side. Now it's 2y equals 4, which means where does it hit at? 2. That's this point right here. Okay? Then it says I want to stay in the first quadrant, so I'm going to shade right here. And now read the instructions. It says find the volume of the solid generated by rotating region R around the y-axis. So this is my center, and I'm going to be spinning it this way. This way. So it's going to be like this. So your other half of your region is going to reflect across the y-axis. Yes, ma'am? Yes, and let me say as well with that, if you don't know how to graph these, solve it for y equals, and then just graph that line. It'll be the same. Okay, so if you're not sure, you can always resolve it for y equals, and then it'll be like a normal y equals mx plus b, and you can graph it from there. Okay? So here's my graph. Draw in one of your circles. And how do you notice that your radius runs? Instead of top minus bottom, now it runs right minus left. So let's put in our radius here. Okay, r of y equals. What was my right side of my radius? Negative 2y plus 4. And what is the left side touching? 0. Because it's the y-axis. Okay? Then it says find the volume, so we're going to do v equals pi integral. What are the boundaries? They need to be y values. Y equals 0 to y equals 2. And then it's pi r squared. This is my r. So it'd be negative 2y plus 4 squared dy. And then the big things to remember are that everything should be y's if it's a dy integral. These should be y's. That should have y's. You shouldn't have any x's in your integral if it's dy. Okay? Then this one, you could square double square it, or you could do u sub. Either one would work. Okay, go down to number 6. Yes?
I don't know when you said will work. Like, remember the last case where it looked like it would work? The chain rule do.
Okay, so if you pick your u here, what's your du going to be? Just a negative 2. Can you pull that out to the front? Yes. The other one, your du had an x in it that wasn't going to cancel out. So that's kind of how you can know, is if you have an x in it that's not going to cross out, that's when u sub won't work. Okay? All right, go down to number 6 for me. Oh, and then did you have a question, Marisol?
So say you know if you have to put y and everything.
Uh-huh.
Would it be like forget actually put like x but still get the same answer?
They might not count that. For a free response. Multiple choice, as long as you know what you're doing, that's all that matters. But if you put a y instead of an x, that might not get points. Okay, so x squared is here. Yes? Yep.
Number 5, if you use u sub, you plug the endpoints into the u, wouldn't you get negative 0 and 4?
Yes. Nope. Okay, so let's work it out just since let's work it all the way out. So my u would be what? Negative 2y plus 4, which means that my du is negative 2 dy. So far, so good? Okay, then my dy has to be du over negative 2, right? So we're going to rewrite our integral. It's going to be u squared du, but then because I had this over negative 2, I'm going to put it in the front. Okay, now we're changing our endpoints. Remember, to change your endpoints, you're plugging these two guys into your u. So for the top point, I'm plugging in 2. Negative 2 times 2 is negative 4, plus 4 is 0. On the bottom, I'm plugging in 0. 0 plus 4 is 4. Now, Salamuddin's point was that those come out backwards. You can change it if you want to, but you don't have to. It works itself out. Watch. What's the antiderivative of u squared? Okay, I'm going to put the 1/3 on the outside. I have my pi over negative 2 out here as well. Okay, then I'm going to plug in 0, then I'm going to plug in 4. What is 0 if I cube it? What is 4 if I cube it? 64. And if you didn't know that, what would you put? 4 cubed. That's fine. Okay, and then what happens when I do 0 minus 64? It comes out negative, and what's on the outside? Another negative. Those take care of each other. So if you want to, you can flip it and take this negative out early, or you can just leave it alone and it works itself out. So I'd have negative pi over 6 in the front, and then 0 minus 64 comes out to be a negative 64. The negatives take care of themselves. So it would be 64 pi over 6, but it does come out to be positive because the u sub just kind of fixes itself. Okay? Yes?
So if that negative is in front, you would have
No, you never have to fix it. Because if the negative hadn't been in front, these wouldn't have come out to be negative. So it's like all of it like relates to itself, to where it's like if you fix it, you'll get the same answer as if you'd left it the same. Okay? So take a look at number 6. We want y equals x squared, the y-axis, and y equals 9. Okay, then it says find the volume by rotating region R around the y-axis. Now keep in mind that if the y-axis is a side, am I shading the whole parabola-y thing? If I want the y-axis to be a side? No, you're only doing one side or the other. And then if I'm rotating it around the y-axis, that means my reflection is kind of already drawn for me over here. There's your circle. Which means that my radius is here. Notice that it's running sideways. So r of y equals, and I know it's going to be right minus left. Now, here's the problem. When I go to write it, what is my equation written as? Y equals what? Y equals x squared, right? Is that going to work if it's dy? No, we're going to have to change to x equals. So if it's y equals x squared, then what does x equal? Square root y. Now technically it's a plus or minus, but since I want this one over here, this is going to be positive square root y. And so now when I do right minus left, my right side is square root y. What's my left side? What's my center, if you will? 0. So it'd be root y as my right side minus the y-axis, which is 0, as my left side. And then remember, volume equals pi integral. And then whatever my radius was squared. So if it's square root y squared, that would be my radius in the middle. And then what would my endpoints be? 0 to 9. Okay? Now on that one, if it's square root and squared, what is that really the same as? Really, that's just a normal y in the middle. And then you would do the antiderivative of that. What is the antiderivative of y? Okay, so pi halves y squared, plugging in 9 and 0. Okay, 9 squared comes out to be 81. 0 squared comes out to be 0. So your final answer would have been pi halves times 81. Okay. All right, last one like that. Take a look at number 7. Okay, I'll give you a second to sketch the graph. Okay, it says square root x minus 8, x equals 8, and y equals 2. Which way is this guy shifted? Left, right, up, down. To the right, so 1, 2, 3, 4, 5, 6, 7, 8, and then square root. And then it says the line x equals 8. Well, if I moved it over 8, that's ending up right here where I shifted my parabola. So they're already touching right here at 8. And then it says y equals 2. We'll say that's here. So I'm going to shade my little triangle region right here. And then what am I going to rotate it around? X equals 8. So notice if x equals 8 is here, then when I flip it across, it's going to end up here. And that's going to be your shape rotating around. Okay? So it'd be kind of like a funnel with the pointy part down. Okay, so write down your radius for me. R of y equals. And then what do I notice is wrong with one of my borders? This one is x equals 8. But what's wrong with the curved one? Right now it's a y equals. It needs to be an x equals. So I'm going to take my square root y, x minus 8. And I'm going to have to change that to x equals. So square both sides, square, square. That means that y squared is x minus 8, which means that x, when I move the minus 8 across, is equal to what? Y squared plus 8, right? And that should kind of make sense that it's like a parabola, but it's shifted over 8 and then it opens to the right. So that should kind of make sense in your head that that's the same graph. So when I do right minus left, what is the right side touching? Y squared plus 8. And what is the left side of the radius or the center touching? 8. And when you have a plus 8 and a minus 8, what's going to end up happening? Just like the 4s on the other problem. Cancel out. So really your radius is just a what? Y squared. Uh-huh. Okay, so then it'd be integral where to where?
What about the pi?
Oh yeah. Pi 0 till 2. And then it'd be your radius squared, which is y squared squared dy. And then y squared squared is the same as what? Y to the 4th. And then you do your antiderivative, plug in your crap, blah, blah, blah. Everything works out easy. Okay? Do you have any questions? Okay, we're going to do more of this, but it's going to keep getting harder. So bring your brain with you every day. Okay? No. What? No, you did not. You did not lose it. I'll see some of you guys after school. Study party.
Is it today?
What time is it?
Yeah.
Like right at 5. Really, it's supposed to be 5:15. So when I meet with Miss Gibson, she might tell me they have to go till 5:15. But we'll see.
Is it today?
Huh? There's one today, tomorrow, and Thursday. And then Malpa Theta's on Wednesday. That's it.
I have to sign up.
Usually I make like 10 extra copies, so. You don't have to cross it out. That's okay. That just helps me estimate copies, so you don't have to mark your name off. Huh? Today's derivatives and tables.